Welcome to this explainer. If you've ever stared at a dense, intimidating wall of trigonometry formulas and just felt completely overwhelmed, well, you're definitely not alone. But today, we're going to completely reframe that scary wall of equations into an elegant, easy-to-navigate map.
We're going to kick things off with this crucial quote right from our source material, because honestly, it fundamentally changes how you should look at math equations. You shouldn't view them as separate, rigid rules you've got to memorize, but rather as different pathways. They are literally all just different doors leading into the exact same room.
All right, so here's our roadmap for today. We're going to cover doors to the same room, the foundational triangle ratios, the Pythagorean master key, halving and doubling angles, chords, arcs, and versines, and finally, we'll wrap it up with the big picture. Let's jump right in. Section 1. Doors to the same room? All those overwhelming lists of equations you see in trigonometry, they're actually just different ways to arrive at the exact same answer.
To open these doors, we first need to get comfortable with our central symbol here, the Greek letter phi. Now, when you see this pop up everywhere, don't let it throw you off. It simply means the angle we are working with. It's basically our anchor point for whatever scenario we're looking at. Moving on to section 2, the foundational triangle ratios. This right here is solid ground zero for everything we're going to discuss today. This brilliantly illustrates the starting points for pretty much everything in trigonometry. On the left, we have the big three, sine, cosine, and tangent. And look how cleanly they map to their reciprocal partners on the right. Cosecant, secant, and cotangent are literally just the basic functions flipped completely upside down. Just as a quick refresher on our basic right triangle, these three core ratios are the fundamental pillars. They relate our abstract angle, phi, directly to the physical lengths of the sides, whether we're talking about the opposite side, the adjacent side, or that longest side, the hypotenuse. To really bring this to life, just picture a simple right triangle with side lengths of 3, 4, and 5. These foundational ratios give us our baseline fractions in an instant. Sine becomes 3 over 5, cosine is 4 over 5, and tangent is 3 over 4. It just goes to show how incredibly simple this ground floor really is. All right, section 3, the Pythagorean master key. Now things get fun, because it's time to see how these simple ratios interact in more complex scenarios. This single equation is an absolute game changer. Sine squared phi plus cosine squared phi equals 1. This is the bedrock foundation that explains so many of those nasty-looking square root formulas you see on a formula sheet. It really is the master key to unlocking the rest of this map. Let's see just how powerful this key actually is. By taking that one foundational truth and just sliding the pieces around using some basic algebra, watch what happens. We move cosine to the other side, take the square root, and bam, we've suddenly unlocked a totally new door to figure out sine, just by knowing cosine. And watch how this logic just keeps building on itself. If we unpack the basic tangent ratio, which remember is just sine over cosine, and multiply both sides by cosine, we effortlessly prove a whole new way to write sine. Sine is simply equal to cosine times tangent. See? You don't have to memorize a single new thing here. You just have to follow the logic. Section 4, halving and doubling angles. Armed with those algebraic master keys, we can now unlock the real secret passages of trigonometry. Check out the perfect visual symmetry here. It shows exactly how a double angle formula on the left and a half angle formula on the right are literally the exact same relationship. You're just looking at them from a different perspective. It's like walking down the exact same hallway, just in reverse. Now, when we're playing with these formulas, the number 45 is incredibly unique in this math landscape. Why? Because the sine of 45 degrees and the cosine of 45 degrees are exactly the same value. That perfect balance makes it a wildly powerful conversion bridge. Because of that 45-degree magic, we can substitute it right into our double angle logic to create what looks like a ridiculously complex formula for sine, which you see at the bottom here. But honestly, when you break it down step by step, it's actually just a hidden algebraic mirror using that 45-degree trick to easily swap between sine and cosine. No magic, just clever math. Next up, section 5, chords, arcs, and versines. Let's step away from pure algebra for a second and wander into the historical wing of our mathematical house, where math actually meets the real physical world. Take a chord, for instance. It's simply the straight distance between 2 points on a curve. If you draw a line from the center of a circle straight to the exact middle of that chord, it creates two identical right triangles.
And that perfectly explains why the half-angle formula is baked right into the calculation for this physical distance. Then we have the height of the curved arc itself, measured right from the middle of the chord. This height measurement was historically called the sagitta, and it was absolutely critical for physical geometry. If you look closely at how it's calculated, you'll see it relies heavily on a very specific term that you would easily find in old-school maritime navigation tables. That term is the versine. Notice that versine is simply 1 minus cosine, and its partner, coversine, is 1 minus sine. Now, you probably won't see versine or coversine in modern textbooks too often these days, but early navigators, they used these exact forms to drastically simplify the complex math of the stars and the seas, way before calculators were even a thought. And that brings us to section 6, the big picture. Let's take all these pillars, secret passages, and historical tools and pull them all together. So when you're faced with a terrifying-looking fraction on a test like cotangent over cosine, seriously, don't panic. Don't look at it as some new formula you forgot to memorize. Just unpack the ratios step by step, substitute in what you know, watch those cosines beautifully cancel each other out, and boom, you're left with just 1 over sine, which leads right back to your basic foundation, cosecant. The whole complex mess just seamlessly collapses into something incredibly simple. Ultimately, the big takeaway from this explainer is that this giant list of equations is not a memorization test. It's a map. It's literally designed to help you navigate from whatever known variables you already have in your hands straight to your solution just by finding the easiest possible route. So I'll leave you with this. If these wildly complex equations are all really just different pathways to the exact same mathematical truth, how might that change the way you approach your next impossible problem? Once you realize that every formula is just a different door to the exact same room, the only question left is, which door are you going to choose to open next?